It's the single most important fuel that keeps the world moving, the backbone of global transport. And its demand only grows as more engines hit the road. Getting its raw material out of the earth is a dangerous and high-stakes business. With turning that raw sludge into the fuel that actually powers your car, involving some seriously advanced refining. Let's trace its remarkable journey from miles underground all the way to the pump. Or if you hadn't, consider yourself caught up. But what exactly is crude oil? It traces back nearly died off, sank to the seafloor, and were slowly buried under tons of mud, sediment, and rock. Inscience. Over millions of years, the crushing pressure and intense heat deep underground slowly cooked that organic soup into a thick and dark. This prehistoric residue now sits at the heart of global trade because it can be turned into an enormous range of energy products. With gasoline taking the biggest slice, thanks to our dependence on constant mobility. Gas prices are in constant flux because they reflect far more than the cost of crude. Every gallon carries the cost of finding the oil, drilling through miles of rock, pushing it through pipelines, refining it, and delivery. That's why prices can spike even when crude itself doesn't.
And all of that effort begins with one essential step: the hunt beneath our feet.
To pinpoint these hidden oil reservoirs on land, geologists use a clever trick called 3D seismic surveying to map out the underground rock without ever digging a single hole. They use these specialized vibroassays, or thumper trucks,
that slam the ground, sending controlled vibrations deep into the earth. And as those energy waves hit different rock strata, they bounce back up to sensors called geophones, waiting along the surface.
Then advanced software crunches that data into a crisp 3D digital map, showing engineers exactly where to set up the drilling site.
Nowadays, most of the big and easy-to-reach oil fields have already been tapped, and one of the most prolific that's still going strong is the Permian Basin.
Stretching across western Texas into southeastern New Mexico. Since 1921, it's delivered around 40
billion barrels of oil, with estimates suggesting another 70 billion still recoverable. This single region alone
pumps out a staggering 50% of all U.S. crude, with its more than 2,000 active wells churning out around 6 million barrels every day.
Getting that black gold out of the ground starts with setting up a mobile drilling rig. Something a well-practiced crew of roughnecks can have ready in as little as 48 hours.
The rig's most recognizable feature is the derrick, an A-shaped steel structure that can stand as tall as 21 stories. It hoists a long string of drilling pipe, tipped with a rugged, diamond-studded, three-headed drill bit. Down on the deck, a diesel-powered rotary table spins.
The whole string at 50 revolutions per minute, slowly cutting a path down into a pilot hole marked by the surveyors. Into this. As the bit grinds deeper into the earth, the friction creates extreme heat and produces heaps of rock chips that would choke the borehole.
To prevent that, the crew pumps this specially made drilling mud down the inside of the pipe. It exits through nozzles inside the bit, cools the cutting face, and flushes the crushed rock back to the surface pits, where the mud is filtered and recirculated.
But since crude deposits can be buried as deep as 2 miles, the drill string needs constant extending.
So every 30 feet, the roughnecks attach a new section, building the string deeper one joint at a time.
Then, to prevent the wellbore from collapsing, they lower in these steel casings and pump cement down through the center,
which forces the cement up along the outsides to lock the casings in place. Once it hardens, it creates a protective barrier, helping keep nearby aquifers and the local ecosystem safe from contamination. It's a grueling and relentless grind.
With the rig running 24 hours, 7 days a week, pushing through freezing cold, blistering heat, and pounding rain.
Eventually, the drill will finally strike oil, and that's when things get exciting.
At first, the reservoir's natural pressure is often strong enough to force the crude upward through perforations inside the pipe and push it to the surface without any help. But that pressure will eventually fade, and when it does, they install this familiar-looking piece of hardware, the pump jack.
The pump jack converts the steady spin of its giant flywheel into a slow, nodding rhythm that drives a pump deep underground.
And with every stroke, another slug of crude is pulled up to the surface. From the wellhead, another pump feeds the oil straight to a sprawling pipeline network of more than 2.5 million miles crisscrossing the country. This underground system is incredibly fast and cost-effective because it eliminates the need for thousands of tanker trucks, making it the safest and most efficient way to move all those barrels. And one of the busiest corridors connects over 700 miles from the Permian Basin straight to the Gulf Coast, where some of the world's largest refineries take over, churning out close to half the nation's gasoline. At first glance, this chaotic forest of giant tanks, soaring towers, and tangled pipelines twisting in every direction is in fact the structured layout of an oil refinery. Every day, it can transform over 650,000 barrels of that tarry sludge
into not only gasoline, but diesel, jet fuel, motor oil, and a host of other petroleum-based energy.
After arriving through the pipeline, the crude gets queued inside these storage tanks, with some large enough to hold 21 million barrels.
To kick off the refining, the crude is drawn from storage and sent through this blistering furnace,
where it's heated to 700 degrees until it fully vaporizes into gases. That boiling gas is then poured into the bottom of the refinery's tallest structure, the distillation tower. And just like steam escaping boiling water, it rises and gradually cools. Inside the tower are tiered levels of perforated trays, each holding a shallow layer of liquid that's kept slightly cooler than the boiling point of the vapor it's trying to catch. Bubble caps on each tray direct the vapor through this liquid, so when the hot gas hits that slightly cooler liquid, it instantly condenses.
Any vapors that are still too light to condense simply slip through the caps, rising to the next cooler tray, naturally splitting the crude
tight into its various fractions as it climbs. At the bottom sits the heaviest semi-solids, like tar, used for asphalt. Above that are lubricants like motor oil, then diesel, kerosene or jet fuel, naphtha, with the second to lightest fraction, gasoline, collecting at the very top. All in all, gasoline accounts for roughly 46% of a typical barrel of crude. That works out to about 19 gallons per barrel. Although it's technically gasoline, what's siphoned off the top of the tower isn't something you'd want in your fuel tank. That raw liquid is called straight-run gasoline. Although it's technically gasoline, what's siphoned off the top of the tower isn't something you'd want in your fuel tank. That raw liquid is called straight-run gasoline. Engine knock happens when the fuel-air mixture inside the cylinder spontaneously ignites on its own before the spark plug ever fires. And before the piston reaches the top of its stroke, that can literally tear an engine apart. This happens because straight-run gasoline has too much heptane and not enough octane. In layman's terms,
It's too eager to ignite under pressure. Between the 1920s to mid-70s, refineries fixed this
by mixing in a chemical called tetraethyl lead to boost the octane. It worked remarkably well, but it also spewed toxic,
Microscopic lead particles out of tailpipes, contaminating roadways, topsoil, and entire cities. Once scientists linked that pollution
to widespread lead poisoning, the government stepped in to phase it out, which led to a clause in the 1990 Clean Air Act
that officially banned leaded gasoline at the pump by 1996. Today, refineries don't rely on toxic lead anymore.
They boost octane by tweaking the fuel's chemistry. First, they take that 50-ish octane straight-run cut and divide it into two upgraded blend stocks, one for regular and one for premium. To create the regular, they reboil the straight run again to split it into heavier and lighter portions. The heavier portion goes to a catalytic reformer, where high heat and platinum catalysts reshape its weak, straight molecules into tight ring structures with much higher octane. The lighter portion goes to an isomerization unit, which uses lower heat to rearrange its straight-chain molecules into branched versions, adding a smaller but valuable octane gain.
They land at a stable 84-octane regular base stock. Then later at the distribution terminal, they mix in about 10% ethanol,
bumping it up to the familiar 87 octane you see at the pump. Premium follows the same path through those reactors, but under hotter temperatures, more pressure, and longer contact time, pushing its base stock up to 90 octane. Before that same 10% ethanol addition raises the final blend to 93. So why do they stop at 84 and 90 octanes when they can just... The answer ties back to the Renewable Fuel Standard, a federal policy that obligates a certain amount of biofuel,
mainly corn-based ethanol, to be blended into the nation's gasoline.
Since ethanol boasts an incredibly high octane of 113, refineries intentionally stop early and let that mandated splash of ethanol do the rest of the job.
And here's some food for thought. The refinery doesn't actually manufacture mid-grade gasoline. If you select the mid-grade option at the pump,
the machine simply mixes roughly 65% regular and 35% premium in real time as you fill up,
with the fuel now upgraded to the right octane for sale.
It leaves the refinery through more buried pipelines to a regional fuel terminal just a few miles away. Here it sits in these giant cylinders that can hold around 50,000 gallons each until trucks arrive to pick it up. This terminal is where those familiar silver tanker trucks get loaded, fit for the trip to your local station. And it's a careful process too. Unlike topping off a car, one slip here can be disastrous.
A metal trailer can accumulate static electricity, so the first step is always to connect a grounding cable, tying the truck to earth, and then attach a vapor recovery hose to pull in any fuel vapors that might otherwise spark. Only when everything is safe and secure do they open the valves and load about 9,000 gallons of fuel into the trailer.
The tanker's interior is divided into multiple compartments called bulkheads, which let the driver carry different grades in a single trip.
This is also where the final touches happen. Roughly 10% of that mandated ethanol is mixed in at the last second to it,
along with any specific detergents and additives that give each brand its own recipe. When the compartments are full, the tanker heads out to deliver.
At the gas station, the driver hooks up the hoses and tops off those 20,000-gallon underground tanks,
wrapping up a journey that began hundreds of millions of years ago and quietly ends every time you fill the tank. Do you think alternatives like hydrogen, ethanol, or electricity will ever fully break our reliance on gasoline? Maybe someday, but for now at least, across highways and cities alike, gasoline still reigns supreme.